Hi and welcome to this video about the so-called forward rate. This video will be part of a whole course at Udemy about the yield curve and its mathematical implications. If you're interested in this, check it out in the video description. Okay, let's start. Forward rate. In order to explain what the forward rate actually is, it's a little easier to describe or think about why you need a forward rate. And the forward rate is usually used in order to find out what a fair price or a fair value of a contract is. A contract that implies lots of years in the future. So we ask the question, if you have a contract that goes about that implies some of the future coming years, the question is, which interest rate or how high will the interest rate of this years to come be? And sometimes if people are about to make a contract, they have suggestions about how the interest rates will develop in the future. But this is not objective, it's subjective. If you are just thinking about what kind of interest rate could be actually in the coming years, for 1 year in the future, for 2 years in the future, for 3 years in the future, and it's not objective. But what we can do is that we can derive an kind of objective interest rate from the yield curve, and then I come to the yield curve on the next slide. We can derive the future interest rates from the yield curve in an objective mathematical way that we could all agree on at the date of contract. And this is why you need the future interest rates, or, as I said, forward rates. Here I have an example. They are needed for products like floaters, or, for example, another example would be a swap, a interest swap. We come to an example with an interest swap in this video. And in order to mathematically derive the forward rate from the yield curve, you need this formula. Now, part of this formula is the zero bond discount factor. I did not write down the zero bond discount factor formula as it is not part of this topic of this video. Maybe I put it down in the description also, but if you're interested in the whole topic of the zero bond discount factors and the yield curve, you're free to go to our Udemy course or just Google for the formula for the zero bond discount factor. I think there are plenty entries that will help you. So the zero bond discount factor can be directly derived from the yield curve, and it's the only thing you need in order to generate the forward rate mathematically. But I know it's unclear what's meant by this. We come to this on the next slides. So therefore, we are going to the next slides. But before that, I want to repeat what I already kind of said in the sentence down here. As the true future interest rates are still unknown, they are future interest rates, and they are not yet generated by the market. And therefore, you just have to guess if if it's about future interest rates. But guessing is not kind of fair if you have a contract with a partner right now. Therefore, you can substitute your guessing by the so-called forward rate. This is a formula, again, that we need for this, but we come to an example later. So the yield curve. Again, I keep it short because this will be part of a whole course, but we have to talk briefly about it. So what is a yield curve again? A yield curve can look either like this in green, the yellow one or the red one. The yield curve can be normal. This would be, green would be the normal case of a yield curve. And the plain one is some kind of extraordinary case. It's kind of unusual. Usually yield curves, usually yield curves do not look like this. It's kind of a way to make accounting, yield curve accounting, more simple, because you do not have compared interest rates if the yield curve looks like this. Or we can have the inverse case, which will be also kind of an unusual case, but you could also find it at the market in recent times more often than before. So what does this yield curve tell us, or these yield curves? These yield curves tell us what kind of interest rate or how high the interest rate is if you have a contract that is about a certain time in years. Meaning, if we have a contract starting today would be here, and the contract will go over 1 year, we will get 3 different interest rates out of the market yield curve. You would just have one yield curve at the market right now. These are just 3 examples. So let's suggest that the yield curve would look like this, like the normal curve. I mean, it would have more of a curve form. This is a line, but I think just for an example, it's okay at the moment. So we start here and we will go 1 year and we would get an interest rate of 1%. Then if we have a contract that will start right now and go over 2 years, then we would get an interest rate about 2% for this contract. And if we have a contract starting right now going over 3 years, then we would get a interest rate of 3%. So we could also interpret what I already said. The interpretation would be that the longer a contract goes, the longer the money is bonded onto the contract, the higher the interest rate has to be. And it's kind of a usual thing, of a common way of thinking, that the longer money is gone, the higher the interest rate has to be in order to make a fair contract. So the normal yield curve would be the intuitive case for contracts. But you can also see that sometimes the market gives some kind of this yield curve, meaning that the shorter money is held in a contract, the higher the belonging interest rate will be. This is some kind of unintuitive and some kind of unlogical, but still you could see it sometimes at the market. The yield curve is achieved by the actual market right now. The yield curve is not something that someone is forecasting, some institution. It's something that is just derived by the market that you can see now, that is right now ongoing. And it can be derived from some kind of financial contracts that are part of the market, as the yield curve itself is not traded, but some products are traded where the yield curve can be derived from. So we're having the different yield curves, and I come to one more thing before I continue. There is a common mistake people often do if they first handle the yield curve or first meet the yield curve, and it's that they think that the yield curve is some kind of forecast, that if you are here in t is 0 equals 0, meaning today, that you can just read off this graph how the interest rate will be in, let's say, 3 years. So somebody could suggest that if you see this and you want to know how the interest rate will be in 3 years from now, you just take this graph and you look at it and see, okay, looks like we will get 3% interest rate in 3 years. Attention, that's wrong. It's a wrong and a very common misinterpretation of the yield curve. The yield curve does not directly forecast the interest rate. The yield curve does say us, in our example, how high the interest rate would need to be if you will do a contract, a fair contract, from today about 3 years from now. Meaning you have a contract ongoing for 3 years, and then you usually at the actual market you will get an interest rate of 3%. That will not imply that the interest rate in 3 years will be 3%. That's wrong, and it's a very common mistake. Why am I so pointing on this problem? I'm pointing on it because the forward rate is the one who's telling us how the interest rate, the actual interest rate, will be in the coming years, deriving from the actual yield curve that we can see now at the market. And with this tool, we are able to make an objective price or an objective value on a financial contract by just using the market right now, the market numbers right now, the yield curve that is right now at the market. So it's a very elegant way to actually find a fair and objective value of something that will be ongoing in the future, the forward rate. So here is the mathematical part of it. Again, it's just the formula you already know from slide 1. It's the interest rate, and this is how to read it in the brackets, you see t and 1. 1 is fixed for 1 year, and t is your starting point, your starting year. Meaning, if t is 1, then you will have the interest rate from 1 year in the future, about 1 year long, that will be actually ongoing for 1 year, meaning that this would be the interest rate from year 1 to year 2, seen from today. So 1 year in the future to 2 years in the future, the time between and the interest rate that will be actually for this time frame. So that's also how to use the formula. If you're searching for the forward rate from year 1 to 1, then you need the zero bond discount factor from from now to year 1, and it's divided by the zero bond discount factor from now on to the year we start plus 1, making it the year the interest rate will end. And all this minus 1 will give you the forward rate. I calculated the zero bond discount factors from an example from a normal yield curve that can be seen at the market. And therefore you have these 3 zero bond discount factors, and you just put them into the formula for the forward rate from 0, so from today, to 1 year in the future. It is logically the so-called spot rate, meaning that the spot rate is the interest rate that is now seen at the market. You do not need a forward rate in order to know how the interest rate right now will be. Just look at the interest rate right now. So it's very easy to use it. So you have one part of the zero bond discount factor, as there is not one for the time now, and you get 2%. The forward rate from year 1 to 1 is again from 1 to year, also from 1 year in the future to 2 years in the future, is this zero bond discount factor 0 to 1 divided by the zero bond discount factor from 0 to 2 minus 1 will give us 4.1%. So this will be, seen from right now, the fair forecasted interest rate derived by the market right now between the year 1 year in the future to 2 years in the future. 4.1%. The forward rate from... Oh, this is wrong. I made a mistake here. Sorry. Again, it's the forward rate from year 2. I should have put the numbers for the T. I'm sorry, but I think you know what I'm talking about as I explained it. So from year 2 starting, again 1 year obviously, equals forward rate from 0 to 2 divided by forward rate, zero bond discount factor from 0 to 3. Minus 1 gives us 6.2%, meaning that the actual fair interest rate predicted by the market right now for the year 2, from now on 2 years in the future to 3 years in the future, 1 year of time, will be 6.2%. So these will be the fair forecasted by the market right now, objectively forecasted interest rates for 1 year in the future, 2 years in the future, and 3 years in the future. Now, as this was quite theoretically, we will have an actual example of this. I don't know if you're common with swaps. I think some of you might be, so I will just explain it very plainly. A swap is a contract, a financial contract, where you switch interest payments from fixed to variable, or from variable to fixed, depending on of which way you look at it and which contract partner you are. And as there is a contract partner paying fixed and receiving variable, and the other is paying variable and receiving fixed, they are all interested in a part of this contract, and a part of this contract is which kind of variable interests payments will be coming, will be actually ongoing in the next years. And again, if they would not have the tool of forward rates, they would have to guess. They would have to agree on some kind of interest rate they think that will be actually happening in the future. But they don't need this. They can objectively derive the future interest rate, the fair future interest rate, from the market right now by using the forward rate, using the yield curve. So the cash flows of the variable side, and we're just looking at the variable side obviously of the contract, because the fixed side is forecasted as it is written down in the contract, the interest rate that has to be paid or has to be received, respectively. So the cash flows of the variable side of a swap contract can be predicted by using the forward rate deriving from the yield curve. This is just again what I already said. And now we will see what's going on in our example. We have an example, a swap contract ongoing about 3 years in the future. Meaning from today, t equals 0, to t equals 1 year in the future, to from year 1 to year 2, 2 years in the future, and from year 2 to year 3, 3 years in the future. And we are interested in which kind of interest rate will be actually ongoing from here to here. This is the spot rate. Again, we can already see it at the market. Therefore, we do not need the forward rate. We need the spot rate, which equals the forward rate in this case. So it's quite simple. But here, the need for the forward rate starts because we need the interest rate that will be actually happening in the year from year 1 to year 2. And again, we go one slide back. This is, we already calculated it from the zero bond discount factors, directly derived from the yield curve, will be 4.1%. We have a contract of a volume of 1,000, whatever this is, dollar, euro, yen, put some something behind it. So 1,000 make $1, and we first have the spot rate of 2%, meaning we have to make a payment of 20 euro, or we will receive a payment depending on of which way we look at the swap contract. But in this example, we would get the variable payments of the swap contract. We would have to do the payments of the variable swap contract, meaning we have to pay the variable interest rates. And as the first interest rate will be 2%, we will have to pay $20 to year 1, then we will have to pay $41 as it is 4.1%. 4.1% times 1,000 is 41. And then in the end, we get the whole volume. We get to pay the whole volume, and again an interest rate of 6.2%, as we already calculated. And by this, we will have the whole variable payments. And now we'll make it a little more interesting, because these are just the cash flows. As already written down here, it's what is paid, the cash that is flowing. But we can have the actually value of the cash right now. And in order to get the value, you can also use the zero bond discount factor to get a future value, or the actual value of future payments, as they have to be discounted. So we again use our already known zero bond discount factors. For year 1, it will be 0.9804%. Sorry, this should be a point. It's overtaken from German, so just ignore it. And minus 20 times 0.9804 is, oh, you don't see it yet. You first see all the zero bond discount factors, meaning this is the zero bond discount factor from 0 to 2. This is the zero bond discount factor from 0 to 3. And you have to multiply the cash flows in order to get the actual true nowadays value for the future payments, the discounted value. So minus 20 times 0.9804 is minus 19 point, here it's right, 61, minus 38.61 and minus 941.89. If you sum up all these, so this is the actual true value, the discounted value of the payment right now, the cash flow right now. As it is taken right now, you do not have to discount it, it's the same amount. But these are the discounted cash flows of the future. And if you sum up all of them and calculate them against the 1,000, you get a present value of 0. So, and this is very interesting in order to get a deeper understanding of the forward rate and the yield curve. Meaning, we are able to achieve a contract where the future payments are discounted by the actual market, by the yield curve of the market, and we get a fair value of a present value of 0, meaning in this contract right now, seeing the market, seeing the actual market yield curve right now, no contract partner wins, as it has an intrinsic value of 0. It's just a fair deal, objectively derived from the yield curve at the market. So I hope I could help you with the topic of the forward rate. I think if you just watched the whole video, you have a certain idea about it. And I'm sorry that I do not put down the formula for the zero bond discount factor. Maybe I put it down in the description, but I think you'll find it anyway. Thanks for watching.